Hey, Mike Pinto here. I'm going to take you through the process of designing and building this custom acrylic pedal board. I like building pedal boards out of acrylic for a few reasons. One, it's a versatile material that comes in different thicknesses and it can be cleanly cut to any size or shape that you want. Two, because it's so smooth and glossy, sticky back Velcro and rubber feet stick to it really easily, which is a big bonus. Three, because you're custom building it, you have the option of building some legs and making it sit on an incline, or, as I did here, making it sit flush to the floor. And four, again, because you're custom building it, you can choose whatever case you want. So you pick your dimensions for the board, make sure that it fits in the case, and you're good to go. I've built pedal boards out of acrylic before, like this one, this one, this one, this one, and this one. But with this project, I took the design and the fabrication to a new level. I created vector artwork in a graphics editing software. I sent that artwork to my plastic supplier and they laser cut this piece to match it exactly. And so this piece cost about 50 bucks. That's for the material, the setup fee, and the laser cuts. When you add the price of a case to that 50 bucks, you're probably in the ballpark of a pre-made pedal board solution, but with two big benefits. One, you've got a totally custom piece which fits your gear exactly and looks cool and unlike anything else. And two, you can choose whatever case you want instead of being stuck with whatever case comes with your pre-made pedal board solution. Now you're probably wondering about this setup. It's kind of unusual. I've got these two volume pedals, I've got multiple Zoom multi-stomps here. I'll get into all those details in another video, but for right now, I'll just say that I designed this board to work with this guitar, affectionately known as the Uber guitar. It's built around the Graphtech Ghost pickup system. So I've got electric and acoustic guitar sounds coming from this same instrument. And this board is designed to handle both. So both of these Dunlop VolumeX pedals are heavily modified. This input box here is built from scratch. Again, I'll get into that later. Right now, let's get into what it takes to actually build something like this. So first, I laid everything out. I used cable plugs to ensure proper clearance around everything, and I did the same with the DC power cables. I decided the final dimensions would be 12 by 18 inches, and I marked it with tape. I then decided on the exact sizes and locations of the cutouts I would need to neatly run all the cables. As I worked, I transferred my measurements to a cheat sheet I'd eventually use when creating the vector artwork. This all took some time, as there are 7 cutouts within the board and 3 around the perimeter. I took special care on the cutout for the power supply, as I'd be using all 8 outputs and I wanted the 8 cables to have enough room and to be run neatly. I also took special care on the cutouts for the 2 rocker pedals. With my modifications, 5 of the 8 total jacks would have cables plugged in and run under the board, so again, I wanted them run very neatly. With the cheat sheet done, I was ready to create the vector artwork. I used Inkscape, a free open source vector graphics app. After setting up the document dimensions as 12 by 18 inches, I set guides at the correct measurements for the perimeter and made a rounded corner rectangle, snapping it to the guides. I followed the same process for each cutout. All of these shapes have a simple black 1-pixel stroke and no fill. The cutouts along the perimeter required some more complex editing of the path nodes, but this wasn't too hard. Then I was ready to print a full-scale draft copy and try it out. I had to tile print it across 4 sheets of paper and then cut and tape them together. I set down all the pedals, checked the fit, and after a few revisions, I finalized the design. I sent an EPS file of the vector artwork to my plastic supplier. They laser cut a piece of 1/4-inch thick black acrylic to match, and I'm thrilled with it. Here it is as it arrived to me, with protective paper on the glossy surface. For my previous projects, I'd only ordered flat board cut into plain rectangles, never with any cuts based on vector artwork. You can see the cuts are really precise. It's an exactly accurate representation of the design I created on screen, and it's really neat to hold it in my hands. Next, I wanted to double check the dimensions, so I started by setting the power supply in place. So far, we're looking good, but I made a boo-boo. I forgot about accessing the switches on the bottom of the power supply. I'll have to make a hole. So I started with the tracing and then set to work with my Dremel tool. First, I drilled 4 holes, and then I used a cutting bit to connect the dots. I sanded it a bit, and although it looks rough compared to the neat laser cuts, At least it'll be hidden from the top view. Next, I drilled holes for the rubber feet. Here you can see how much the board flexes, but with the rubber foot more or less centered under where I'll be stepping on each pedal, it won't be an issue. As I said before, sticky back rubber feet work great on acrylic, but I happen to like these particular feet, which aren't sticky back, and they work well with rivets. And it's also kind of fun to use the riveting tool. Here you can see all 8 feet attached and how sturdy it is. Here's the bottom, and you can see how I put a couple washers in between the board and the feet to offer a little extra clearance for the cables. Next up is Velcro. Most of the pedals already had Velcro applied, so here I'm applying it mostly only to the board. Time to check how well everything's sticking, and we're looking good. Just need to attach the final 2 boxes, and we're done with the Velcro. Next, it's time to route and dress the power cables. First, I plugged all of them into both the power supply and the pedals, and routed them through cutouts in the board. I used masking tape to mock up how I want the cables routed on the underside, and then removed the tape to start securing the cables for real. This is the fun and tricky part, as unlike the audio cables, the power cables aren't custom made to exact lengths, so routing them neatly requires some creative maneuvering. In the places I used tape, I stuck cable bases and loosely zip-tied the cables to them. When I finished adding cable bases in this part of the board, I nudged the cables around a bit more, tightened the zip ties, and clipped off the excess. Then I started the same process on this other part of the board over here. There was enough excess cable length here that I looped the cables around a few times into this circle. And here are some close-ups of how the cables are routed and attached. Okay, next it's time to make the audio cables. I used George L's cables. They sound great, the plugs and wire are small so they don't take up a ton of space, and most importantly, they're easy to make. You just press the wire into the plug, bend it back, and screw the cap on. And then I tighten it more with some pliers. After making the first end, I plug it in and then check how long the cable needs to be before cutting the wire. Assemble the other plug, and you've got a finished cable. After that, I assembled the remaining cables. I needed 7 total, which is not all that many, but taking care to make them all to the correct lengths takes a little bit of time. I plugged in a guitar and amp, tested everything, and it worked great. Time to route and dress the audio cables the same way I did with the power cables, with cable bases and zip ties, making sure all the cables are neat and tidy. Repeat for all the cables, tightening the zip ties and clipping off the excess as you go, and eventually, it's finished. Time to go make some music.